Hi, Geometry. So I'm just going to be going over your first objective of the day with you guys. So please make sure that you write this in your notes. Objective 1, to define and name polygons, discover the sum of exterior angles. Okay, so here are some examples of polygons and non-polygons. And you can figure out what polygons are just by looking at what non-polygons are, right? So I want you to take a second and try to determine the differences between the bottom set of images and the top set of images. And you can go right ahead and pause the video. But if we look at the bottom left one, right? The bottom left one is open, right? This polygon up here is not open. So we know that polygons must be closed. So this is a non-polygon because it's not closed, okay? If we look at the second example, okay, we know that this polygon has a curve, okay? In comparison to the three shapes up here, this curve makes it a non-polygon because polygons should have straight sides only, okay? And then looking at the third example, all right, there's a major difference between these two, and we learned it before when we discussed dimensions, okay? This image right here is 3D, this image up here is 2D, so we know that polygons must be 2D. So here you have your notes. Please make sure that you are writing that. 2D, polygons are 2D, flat, closed shapes with straight sides, as discussed in the last one, okay? Then we're gonna look at the ways that we name polygons, right? So we name polygons based on the number of straight sides that it has. So if it has 3 sides, we use the prefix triangle because it has 3 angles, okay? Quadrilateral, quad means 4, pent means 5, hex means 6, oct means 8, and deca means 10. Now these are not the only ways to name, or these are not the only prefixes that you will use. These are just the most popular ones that you will see in geometry. I do want to challenge you guys to try to find out what more larger sides mean, or like what their prefixes are, okay? So we have regular polygons, right? And then we have irregular polygons. So I want you to take a second and try to figure out, again, like what the differences are, right? You can compare them top to bottom, right? And just notice, right? So it looks like, let me go back, right? Polygons have straight sides that are pretty much equivalent or the same, right? So if I look here, it looks like all of these measure the same. If I look here, it looks like these top and bottom sides are a lot smaller than the sides on the left and right. And the same thing applies for this image and then for this image. This side right here is much longer than the rest of the other sides, okay? So a polygon is regular if all sides are equal and all angles are equal. So if we go back to the image, right, it would be irregular if, so I want you guys to kind of like think about that, okay? So we know the interior angle measures for these polygons based on the number of sides that it has, okay? So in this first example, right, I know that the total number of degrees inside of a polygon is 360. So since I have 3 angles in here, I do 360 divided by 3 and I get 60, 60, and 60. Sorry, I'm so sorry. The inside of it is not 360, it's 180, okay? 360 is the measurement for rotation. So please don't make the mistake like I did, okay? These small ticks on the side that you see, like as you can see here in the notes, that just means that the sides are congruent. So that means that 1, 2, and 3 measure the same. 1, 2, 3, and 4 measure the same, okay? Now we look here again, and we can tell that that's 108 degrees. This is 135 degrees, and this is, once that little thing goes away, I can actually, you know what, we'll move on. You guys have the slides, okay? So now if we stop, right, and we look at the stop sign, what would be the name of this polygon? Feel free to pause the video. So this would be a regular octagon. And as showed before, oct means 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 sides, and it's regular because they're all straight, none are curved, right? And they all are measured the same size. So this is a blank because it has 6 sides. So I look at 6, the prefix for 6 is hexa, so it would be a hexagon. And it is a blank because not all sides and not all angles are the same measure. Well, we looked at regular versus irregular, and I know that this is irregular because not all sides measure the same. Not all angles are the same measure, okay? So here is a real life example. We have this building in Washington, D.C. that's very popular, and we know it as a pentagon. And the reason why it's a pentagon is because obviously penta means 5, 1, 2, 3, 4, 5, 5 sides, y'all. Now we're on to the next set of notes. Please take a second to copy this down. Feel free to pause the video. Okay, so you will see shapes that have like an extension with like an arrowhead. Now that just goes to show you guys that this interior angle, it's what's inside right here, versus the exterior angle versus what's outside over here. This is the interior because this shape is closed off, okay? It's closed off, there's no opening. This is the exterior angle because it keeps on going, okay? So if I know, right, I'm looking at an angle, right? If I were to draw this little line, imaginary line over this, I know that it would have to measure to 180 degrees because if I were to rotate this some more, right, under here, it would measure 180 degrees. And remember, like the mistake I made before, a rotation is 360 degrees. Inside of a shape, the total is 180 degrees, okay? So if I know that this measures 180 and I have 60, as we've done before, we simply subtract. 120 plus 60 is 180, okay? Now let's look at this one. We know that, again, this is a supplementary line, right? We know that this is supposed to measure 180 degrees. So if I have 108, how much do I have left here? Feel free to pause the video, subtract it. You should get 72 because 108 and 72 measure 180, okay? Again, under here, completely is 180, so that means that up here should measure 180, okay? And now we have another example. Please feel free to pause the video and do your subtraction, okay? Same as above, as the last two. These are supposed to equal to 180. 180 minus 135 gives you 45, okay? So here's some thought. Why do you think the exterior angles of these polygons, what do you think the exterior angles of these polygons add up to? Does it depend on the number of sides? So feel free to pause, think about it, okay? I may have given it up already. I may have not, all right? So we know that the sum of exterior angles of any polygon is 360, right? The sum of the exterior. So that means that it doesn't matter how many you have, 1, 2, 3, and 4, they should always add up to 360. The inside is what measures up to, that adds up to 180, okay? And that wraps up your first objective, okay? So just make sure you got these notes in your notes. And if you have any questions, feel free to, reach out and yeah, make sure you get those notes.